Vuoi iniziare così tu? Vuoi iniziare così tu? Ok. Allora, buongiorno, sono contento che siamo numerosi oggi per il lancio, diciamo così, del progetto The Big Data Law. And now I'm going to switch in English because everything is supposed to be in English. Okay, so welcome and thank you for being here. This is a project that has been funded by the University of Padova, recognizing as innovative and interdisciplinary project that of interest for our university. The idea of the project basically come from some discussion that I had with my colleague Professor Pin and other colleagues of the departments, and we are recognizing the importance of stimulate, let's say, a critical discussion and thinking about consequences of technology, in particular artificial intelligence, on our society. So the structure of the seminar, and then I will lead the word to Professor Pin. The structure of these cycle of seminars is the following. We will basically have one seminar per month, and this next seminar, for example, will be in this room on the 9th of November. And then at the end of the series of seminars, we'll have a mock trial that Professor Pin will then explain in details. And also he will point out that it's possible to have a certificate of attendance of these cycles of this series of seminars. And finally, we want to show the main tool that is the tool that we basically want to develop during this year with materials, videos, and discussion, that is the website. Okay, so I just point out, this is the website, and the final URL will be available soon. We will advertise and communicate to you the final, actually we have already the final address, right? But anyway, we'll be communicated to you all. So the structure, as you see, is the following. There will be a chapter, let's say, of the website dedicated for each of the seminar that we will have this year. For each of these seminar will be the video we are streaming now, and then also materials related about the seminar. So I just want to now ask Professor Pin to introduce the mock trials.
Thank you very much. Good morning, everybody. Actually, good afternoon. We thought that part of the education process is having fun. If you have fun while you're doing something, then you learn more. And one of the ways we can have fun when we study law is making up a mock trial. So it consists in creating a sort of trial within which parties, litigants argue against each other in front of a court. And we will gather people of different disciplines and judges to adjudicate cases that have to do with big data. So we are inviting everybody, not just students pursuing the law degree, in participating in the mock trial, because this will be an excellent exercise to understand how big data and law come across, and how law process big data, and what are the expectations of law towards big data and towards people who process big data. And this is why it's supposed to be an interdisciplinary endeavor, and you are all invited to participate in the mock trial. When you leave, hopefully not before the end of this whole lecture. When you leave, you'll find sheets outside. Please leave your name and signature. This will enable us to give you a certificate of attendance if you get 75% of the lectures. And you can also have the possibility of saying, yes, I'm interested in participating in a mock trial. If you tell us what your program is, then we will be able to shape the mock trial depending on the energy and other resources and of your skills. So I'll give the floor back to Professor Samir Suweis, and I look forward to having all of you involved in the mock trial.
Yeah, thank you. Since the beginning, it's clear that we really want to expose different approaches and disciplines and really try to understand which are the critical points that can emerge when we are dealing with the artificial intelligence and big data in society. That's why we will have also invite speakers from different academic institutions, probably also from companies that has to do with big data, and so also we'll try to tackle real problems in the mock trials. So that's why I invite everybody, as Professor Pin said, to join this mock trial at the end of this cycle, so will be basically next year. So this is the first seminar of the series. It is just to just give an overview of the problem, maybe, and some insights about future lectures that we will have in this series of seminars. I will create this hashtag, the Big Data Law, so you can follow and some of the news about seminar dates, web address, and so on will be also devoted through this hashtag Big Data Law. Okay, so this is my Twitter account that I use for work, so you can follow me. All right. So, first of all, when we speak about artificial intelligence, the first point is to understand what we are speaking about. So, in very general way, a machine that try to reproduce cognitive functions, for example, learning, problem solving, it's thought to be implemented through artificial intelligence. So a machine that wants to basically try to tackle, to solve problems that are typical, let's say, human cognitive problems, okay? But of course, this is this is just an operative definition because, of course, simply defining intelligence is not easy. We know there are very many different types of intelligence dealing with different kind of aspects and not only on humans. So it's not easy to define intelligence. Of course, when we want to have an operative definition of intelligence, we need to somehow formalize our idea of intelligence, and this has been done through basically symbolic reasoning. And the idea is that through axioms and logic processes and deductive rules, I can build up thought, mechanicistic thought. And of course, in practical terms, the idea is that I have a problem. I have many different solutions of this problem. I have a state space with different solutions and want to find the optimal way to tackle the problem. And that's why basically the aim of AI is automation of the process. And historically, as I will show in a moment, this really start to try to to formalize the process of thought, okay? So the idea is that intelligence is something, so basically we are rational, I don't know, beings, so the idea is try to formalize and understand how to build up a mathematical structure for the reasoning, from the abstract reasoning. So, as I mentioned, actually this is a very brief history of a long history in artificial intelligence. In fact, we just to think that the first, let's say, approach, tentative to and actually an effective attempt to formalize the process of thought has been made by George Boole. Many of us, I would say, not only know but works with Boolean algebra, and this is the first attempt to translate the formal reasoning in logic propositions. Then Frege basically took a step further and tried to develop a system of notation to automate this formal reasoning. And these are just a few dates, but one very important one is 1936 with Alan Turing that developed actually the first theory of computation. And it showed that through binary calculation, one basically can really translate any mathematical operation into computation. Okay, so this was the real breakthrough in the actual computation capabilities. Then we have von Neumann, of course, that developed the logic structure of modern computers and so on. But the first time that we see the words artificial intelligence was in 1956 during a big conference in computer science where these three guys, John McCarthy, Marvin Minsky, Herbert Simon, among others, basically define the topic of artificial intelligence. And with this topic also, basically they wrote a wish list of research objective that they wanted to achieve in the near future. And among them, there is facial and images recognition, automated learning, language translation, automated programming, proof of theorem, open domain question answering. So all these kind of objectives were already present in 1956, basically. Okay, we'll finally hope to learn how to use this thing. So there was a start full of enthusiasm and also some success. In particular, there was the first program that were able to play chess games and also defeat the amateur in the game. But soon they realized that to really tackle real world problem, it was really a much complicated and challenging task. In fact, after 20 years, basically none of the wish list on artificial intelligence were achieved. And the problem was that for real world cases, there were the boundary condition and the quality of the information was insufficient to really basically automate the algorithm in order to plan and find the optimal solution. There was too many and complex variables that was not possible to put in the algorithm. And I want to stress here, thinking about the example of chess, the idea here, the mainstream was about planning AI. So basically, you know the rules of the game. You can compute possible moves. You can compute a possible response of the other players, and then you can compute again further moves. And so you can build up different game scenarios, choose the optimal one, and then you decide the move based on this path, future path, okay? This was a typical way, the mechanicistic thought was really try to mimic what a real player would do and do it on a machine. And for example, in chess, it was effective. The machine can do really a lot of computations, but actually also was very intriguing because when they moved to professional player, the first time a machine was able to beat the world champions was the famous Kasparov Deep Blue game in 1997. So after basically 40 years of the born day. Okay? And this is the best and the perfect environment to try to implement this kind of artificial intelligence. So this was why during the 80s there was a big cut of funding in the AI. It's called the AI winter, because basically there was this report from this Sir James Lighthill that claimed that basically there was no real result on artificial intelligence. And so at the time they started to cut the funding on the research. I want to start the history. The history is intriguing because we know, okay, that now this famous wish list is basically available in our pocket. We can do most of the objective of the 1956 wishing list through our smartphone. So, what happened? Why after so many failures now we are experiencing this enormous success? And, okay, one, and probably the main breakthrough answer to this question is that we live in an era of unprecedented access and viability of data. This is what is known as the big data revolutions. And what does it mean? It means that we are experiencing an exponential increasing generation of data, not only on availability, but also accessibility and speed. Okay. And as many of the main players in companies like Google recognize now, is that this is really the new oil. Data are the new oil. With data, basically, you can do so many things that 10, 15 years ago you really couldn't even think of. So, and okay, as physicists we know that exponential growth, what is exponential growth, okay, but there's no mathematics, I mean, exponential growth is something that is really counterintuitive growth. We typically have a linear intuition of the things, okay? Exponential growth means that, for example, this is a statement in 2008, I think, of Barry Schmidt, that all the information created between the dawn of civilization to 2003 is the same, it was 5 exabytes, and now this is created every 2 days. This was, I think, in 2011, something like that. So now this information is created in minutes, okay? Today this exabyte of information is created in minutes, okay? So, and together, of course, to the exponential growth of accessibility and speed of data, we have exponential increase of technology. We have smaller and smaller transistor chips, and so we can do more powerful computers, the same cost, basically. And of course, there will be a plateau here somewhere, but still in this moment we are increasing our capacity of computation. So, as a physicist, let's say that we have a long history with data, and also with big data. In fact, I would say that the first sources of big data was really the big collaboration of in experiment like LHC. And for example, in the history of the research in this field, a huge challenge was to be able to understand how to analyze, to filter, to collaborate the amount of data, because the data that this kind of experiment generates is so large, is so big that you cannot even think to look at all the data. Okay? And so basically, historically, for example, also the the internet, let's say, is basically a development due to the fact that the need of putting computers in parallel to work together to analyze data. Okay? So just to say that the traditional source of data, of big data, typically were experiments. But so what it has changed now? Well, we know that the internet is the largest now artificial entities in history, and it creates now zettabyte of data, meaning all informations that we put in the system, that we download, we upload, and we basically the flows of information in the net is of the order of zettabyte. So just to remember here that 1 terabyte, is 1,000 gigabyte, 1 petabyte is 1,000 terabyte. So here we are speaking about millions of petabyte. Okay, so it's an enormous number of information that can be accessed basically from anyone that have a connection. And this is not the only source of data. Now, I mean, there will be this actually already occurring, the Internet of Things, so also connecting a physical object like your oven in the kitchen or whatever, your car will generate data, and business now also, the business is changed, and we have a lot of process-mediated data that is produced by companies. And of course, we have social networks. If you look at the amount of hours of video that every minute is looked by people in the world, or the amount of Twitter, or the amount of posts in Facebook, it's like really incredible and astonishing numbers. Okay, so all of this, all this information, how can be used? Okay, and this is also important for non-specialist people to understand what is machine learning. So you may, for sure, you have, heard about machine learning. So what does it mean? Simply, this is the most first, I would say, application of artificial intelligence, because machine learning is basically algorithms that want to teach, let's say, a machine to learn given a task without explicitly programming the machine before on the specific task. Okay, and the idea is that if you have an index of performance, P, then you have a computer program that learns from some kind of experience, E. Then there is a machine learning if the performance on the task increases with increases of experience of the computer. So, just to make a clear example, let us consider, for example, a program that reads your email, and you're trying to distinguish spam with good emails, okay? And so the task is classifying emails as spam. The experience is the length of the training set, is how many. So you don't, you can have a different approach to do that, right? So, for example, you can basically write an algorithm that say, look, regular email, good email, have this structure. I don't know, the address typically is a name, surname, but then there is a dir, and then there is some object. So you can try to teach, let's say, how is structured a good email, while what's characterized as spam. And based on this information that are the rules, in the example of chess, you try to understand using the program, which is the spam, which is not. Or there is another approach, labels some emails as spam. I know that they are spam, so look, these are spam, these are not spam. And then I simply give this as an input of my algorithm. And then the idea is that if the performance, the ability of the algorithm to distinguish between spam and non-spam increases with the number of training set, the number of emails that I give as an input, then there is a learning that is occurring, okay? And this is just one example, but there are many, many techniques on which you can try to make a machine learn some given task. And sometimes we have that some kind of algorithms, some kind of machine learning techniques work very, very well, but actually we don't know why they work so well, okay? And this will be one of the topics that we want to tackle. We know they work, but we don't know really why they work, okay? And for example, the next talk by Professor Lamberto Ballan will be, he's a professor here in Padova in computer vision, will be about what is the learning through neural networks. Okay, neural network is one of the major algorithms that is used now to do many, many things. And we will try, still in a divulgative kind of approach, but to understand how this works. What does this mean, training? What are the results? What are the critical aspects of a training? Okay, so this will be devoted in the next seminar. So, all in all, the point is that we have a paradigm shift, meaning that most of the algorithm now is different from the planned AI, like the chess game that try to understand, formalize the problem, find the optimal solution. Still, there are important algorithms on this, but the majority of the times, or maybe even better, most of the algorithms that we use every day are not used like that. And the point is that instead of a logic and deductive approach, we have now a statistical approach. Statistical approach means that I show to the machine many, many examples, and then the machine figures out properties that are important for discriminate between different cases, like spam or not spam. And so to do that, you understand that you need a lot of data. So all these algorithms, most of these algorithms were there 30 years ago. The algorithm, there have been some important new step, but most of the algorithms were there in the 80s, okay? But today we have so many data to train this algorithm. That's why are so efficient. And this has enormous success because we are now developing self-driving cars. We are speaking about personalized medicine. Not only chess, but then you can now solve and actually beat professionals in play like poker, that is incomplete information game with stochastic and blah, and yet the machine learning can basically beat the professionals. Or like very complex game like Go, that is much more complex of chess. And so all this new application has basically pushed to a paradigm and cultural shift that I may synthesize in this sentence. Knowing what and not knowing why is often good enough. So basically there is all this movement, and provocatively there was a paper, an article in Scientific American titled The End of the Theory. Because the main idea behind this provocative, let's say, title was that now we don't need a theory, we need to understand, just we can do prediction, and very good prediction with data. Well, in this series of seminars, we want to highlight that this is highly critical. Because if you don't know causal relation, if you're not understanding what you are doing, even with very good result, you can really introduce huge bias, you can do huge mistakes, And this, when these kind of things, these are kind of application, are basically used without any control or any awareness of the limitation, it's really a big problem. So, as a physicist, the interesting point that I discovered in discussion with colleagues is that we are really trained to think about generative causal processes, okay? Newton law, okay? We saw something, we asked why this happened. Well, I think that one of the challenges is that we don't have to, how to say, erase this tradition that we have because it's so important. At the same time, try to use it to complement and to collaborate in the new challenge that we will have to tackle in the next, actually, not in the next future, but already in the present. So I'm going toward the conclusion. Just to say one of the examples of the problem that I just mentioned, this tie, I don't know who of you have heard about it, was like this artificial intelligence from Microsoft. The idea is that was there to help lone people to discuss and have a conversation, but after a few hours that was online, they have to close the project because she or he, I don't know, become like a Nazi, sexist. It took all the worst of the net, and we know that, I mean, it can be very, very bad, and basically, and so after some hours they have to close the account and so on, right? Yes, this is one of the most important points that we will tackle from both a quantitative way with Professor Tina Elisirad from Northeast University. She's a computer scientist, and actually she has really good material in her website. And Professor Simoncini from University of Florence, public law. So in the two sides, we want to understand and really be aware of limitations that basically are due to bias. There are many different kinds of bias that we can introduce in the machine. And so when we use artificial intelligence in different cases, for example, we will discuss some real cases for jurisdictional processes to understand. Basically, the judge has to decide how many years to give, and there is some software that help the judge to understand this based on the history of the jailed or the accused person. But if we have bias, we can really introduce some unfair judgment in the decision process. So this will be in December, and this will be in April. And then the other and the last big point is about the asymmetry of powers. So we know that there are some entities, some nodes that have a lot of data and actually really have a power in the negotiation also of every day when you go to website, we just say yes, okay, because we need to use that website. So actually we just give up our information because we need to use the service. So this introduces some asymmetry of powers and some problems related to the privacy. And this will be another aspect that will be tackled in different seminars from a law point of view and also from a quantitative point of view. As well as the effect of fake news, echo chambers, and post-truth, meaning, for example, this is a snapshot of the network of Twitter in the US, and you can see the two colors. Guess what? Are basically users of Twitters, and the color represented their political parties, let's say, of reference. And so you can see there is a huge clustering, okay, a huge polarizations. And this, we'll see this, how have effect on the spreading of misinformations and of fake news. This will be other seminars. Okay, so now I just pass the microphone to my colleagues, but the important point is that we have really a lot of challenge, And we need interdisciplinary approach to really understand, be aware, and I hope that this kind of series of seminars will help to develop a critical thinking and discussion among us. Thank you.
Thanks for giving me the floor. My presentation will be rather short. I'd like to show you how things are being said resonate with some of the most fundamental challenges in the legal field. So it will be a sort of cursorial review of cases and challenges that we as lawyers are facing with. To some extent, the idea of artificial intelligence has always posed a problem to lawyers, because many attempts were made to create a sort of mechanisms that will make justice and good laws. If you were to ask somebody how politicians should behave, they would say they would need to be transparent, impartial, people you can put faith on. How about judges? Judges should be transparent, impartial. You wouldn't like them to be too full of empathy unless you were the one who needs to defend him or herself. But the portrait is quite distant if you look at artificial intelligence as Professor Suweis has depicted it so far. One of the most obvious issues revolves around privacy. Most of the debates around privacy have dealt with the issue of whether I can take information from you, which kind of information I can take from you. No more information that I need to process your request I should take from you. What happens when you have artificial intelligence, which has the capacity to process that information more accurately and to a larger extent that I would expect as a customer, or maybe that you could ever expect as service provider? What happens if I exploit a third party, like when we make transactions through to the web, right? So do they take into account our privacy? Are they really able to confine themselves to what is needed for our transaction? That's a big question. That question looms large behind the issue of privacy. All companies throughout the world are trying to comply with European data privacy protection, which is EU law regulation that's being put in place. And since we are huge in terms of market, countries from all over the world are trying to comply with our rules to enter our market. What happens? Why is it happening? Why is EU privacy regulation considered to be better than American privacy regulation? Is it true? What are the paradigms? So this is going to be one of the most fundamental questions, fundamental issues that we'll consider during our seminars. But there are even more fundamental and broader questions about the role of law in our societies. We lawyers talk about the rule of law because the idea of law ruling is the idea that the law shapes society, puts checks on society, and is also accountable to citizens through the democratic process. But big data phenomenon is affecting interpersonal relations, social relations, and institutional relations. I already mentioned this. So when you talk about big data, you're talking about massive data. It's huge figures, high quantity of information. How can that quantity of information affect me? I am an individual against the whole internet system. And this is a picture, you may remember that. Many of you might be just too young to remember that. It's a day when Lehman Brothers collapsed and people were immediately fired. So they were just out on the street in New York, Manhattan, and who was to blame? So vast portions of our economy are run according to big data. And big data sounds like an anonymous. Like, who is behind big data? How can I challenge those who process big data and claim that I have been harmed? So there's a mounting wave of mass litigation. People who gather together and challenge big companies who process data to defend their rights. Why this happens? We're going to figure this out together with Beatrice Zuffi, and thanks for being here. Social media. Does this picture say anything to you? Maybe to lawyers? So it's just a very, very recent episode, out of many, numberless episodes. This is Brett Kavanaugh, who was recently sworn in to the Supreme Court of the United States. Judges, in order to be sworn in, need to undergo a very heavy process because they are appointed by the President of the United States, and then the Senate must give its consent. And at the Senate, they undergo hearings during which they are grilled. If you Google that, just to name something that has to do with big data, you will find that he was questioned about things that he said about being drunk during college. And people testified when he was 18, 19 years old about what he said while he was at college. I wouldn't anybody to be questioned about what I said while I was in college. The fact is that thanks to the capacity to process data, our biography is flattened. It's just a very, very big, flat sheet of paper. And everything is in it. The elapse of time does not make your old time, your past fade away. Thanks to search engines, I can look for anybody's details throughout his or her life. This was a big issue which lawyers had to deal with because to some extent, the press has always done the same. You want to know about somebody, you look at the press, right? You go back through the years until you discover something. But who's going to do that? Nobody. Who's going to Google my name after they listen or watch the presentation? Everybody. So, through Google or through other search engines, have the capacity to filter and know of something that I have never come across with in another era. There's a very famous case that started everything. There was a college student in California, I think. She was attending a program to teach small kids, okay? She was in 90s, she was 18, 19 years old, and she was attending that program, and she applied for internship, what Americans do. And people Google her name, and it immediately came out that many years ago she had taken a picture of herself while holding a beer or something, a soft drink, with a pirate bandana on her head, and saying something about how beautiful is it to be drunk. That was all. That sealed her fate. There was nobody willing to hire her because the parents will never accept her to teach classes to their children. You can repudiate your past, but people may not repudiate your past. So there's sort of a reputational game behind here. And that's the reputational game of magnitude that has been unknown to previous decades. This transforms the role of newspapers and reviews. If you have heard of something, you just Google that, right? You don't wait until tomorrow for newspapers to come out and say something that is very disciplined, well-reasoned, and the ultimate word on something. So there's a sort of race to the bottom, even among professional press, that spread news without being able to double-check them, just because they want to beat the competition of media sources. And third, this cuts across what you said before. We have always talked about the open society as one of the most fundamental social institutions of our life. But the creation of echo chambers really challenged that idea. We teach that the best way to fight dictatorship is to allow free speech. You have a bad say, but somebody will criticize you. But what happens if you have echo chambers and you are self-selecting the sources of your information? And if you don't do that, social media will push you because they will nudge you to select some of the sources while they will leave others in the penumbra. This is not just a social problem. That's a political problem. The political polarization in many countries is exploiting social media because it's exploiting the source of information for people. And this touches upon one of the most fundamental institutions that have to do with democracy. Many of us say that one of the relics of all democracy is a referendum, because through referendum you have your say directly. You go to a school building and cast your vote in a ballot. It used to be in the past that people really gathered and decided what to do with their lives. That's not the case. We elect politicians now to do that. But sometimes we do that ourselves. That's an important part of our societies. But what happens if we are misinformed? Misinformed meaning not completely informed. Deliberation is still there, but it's the informational part of deliberation that's still missing. And how can you counter the speech of somebody once it has become viral? Maybe you will reach out to another echo chamber. It will be very, very hard for you to challenge that echo chamber. So there's a sort of dynamic. in place here. And we will have 2 lectures on this. Administrative law. Administrative law has undergone a great process of digitalization. Digitalization means also that you keep some distance between the administration and the citizen. What happens when you have big data involved? On the other hand, we have security and surveillance. I don't need to add words on this, I'm sure. The judiciary, that's going to be the aspect. That's the, when I thought, what would you expect from people who do your job? The VAR. I didn't see something, I'll ask you to help me see something. And you'll spell the truth. Reliable. That was the paradigm. To some extent, you can say that artificial intelligence outsmarts experts and judges because they can process more data than anybody else. But they can be biased. We will see that. Andrea Simoncini, as we said. But since artificial intelligence learns by experience, how can I review decisions based on artificial intelligence? One of the basic ideas of judicial proceedings is that they are transparent. They are open to review. I must be able to review that. How can I review a result from a big data processed phenomenon? I'll make you an example drawn from what you saw before. You remember the bot created by Microsoft, right? They took it out just because it had become a Nazi and sexist oddity. Okay, if I were a penal lawyer involved in a criminal case and I were defending somebody for insulting somebody else or for saying somebody that is obscene and not accepted by society, I would have exploited that bot and said, what does that bot say? It just reflects society. So why is my client charged for having said something that is distasteful since the society at large looks like it's behaving like this? Okay? You can challenge me. We will see that in the future. But you can see the argument. It creates a sort of burden. Show me that the artificial intelligence machine was wrong. Show me that the process was wrong. If you don't do that, I win the case. This is another aspect. And John McCain from Northwestern University will come to speak about the role of artificial intelligence in reshaping the legal profession. And also Paolo Moro from our university will talk about how legal informatics is changing the way lawyers process cases. So, as I said, we were waiting for artificial intelligence to make impartial judges, fair democratic, sure? Excuse me. We have law? Okay. So sometimes it's not that easy. Sometimes laws don't say, if you say this and that, that's obscene. Sometimes laws simply say, if you say something obscene, you can be charged. Who decides what's obscene? Microsoft decided that it was obscene. Society didn't. So it really depends on how flexible is the law in a given country. Sometimes law has become very flexible. And big data can fill the interstitia of laws. That's a phenomenon that's happening. I can see the argument, but that's what's happening actually. I think I'm done. If you have questions, comments, otherwise we can release our audience, I think. Do you want to mic back?
Yes, so if you have questions, so we have sometimes even about what this is overview or on the whole project. Yes, so maybe.
Thank you. Thank you both for your just presentation. And I wanted to ask something about this last case that you explained about the fact that sometimes there is a law that has to rule how something is to be done. Just in case of intelligence, artificial intelligence, or even just the net and social networking, how it is supposed to be ruled, something maybe obscene or something wrong that happens in the net. How do we recollect which is the local rule that has to be followed in that situation, since it's something that is not happening in a specific location? That's what my question is about.
You want to add something? Wait, just wait.
I think if I understood well the question, I think maybe he was thinking about the borderless nature of the internet and which law is applicable, how to maybe choose the law which we apply on a specific case.
That's one of the toughest questions. It really depends. Sometimes, so normally states define the scope of their jurisdiction. So you may want to look at the state and what the state says. But it can happen that both states claim jurisdiction of a certain case. Like, there are cases about it, like the cloud. When you store something in your Dropbox or other cloud systems, where is the information stored? Let's say that you upload in your cloud an information and I am a judge, I want to reach out and get that piece of information. How can I do that? Because if it's within my jurisdiction, I have the capacity to do that. If the cloud is elsewhere, I need a warrant. I need a collaboration from a foreign judge. So where's the cloud? And maybe the judge does not want to help me. And sometimes people decide where to upload their files precisely because they predict that that will be beyond reach. So it's a tricky question, and it really depends on the legal system we are talking about. Each legal system has its own rules. Normally, Europe and the United States are so powerful that they can persuade other countries to do the way they do, sometimes. Sure. Oh, just 1 second. Maybe somebody will be leaving because of the question I've started. Just don't forget to sign and claim your participation in the sheet. For those who are attending my course, let me just warn them that next week there won't be any class, okay? But the lecture does not end here. Floor to you.
No, again, on this thing with the internet and the social medias, I think it's coming as a more and more tough problem. Who is actually intervening and how in the regulation of discussion topics, trend topics, and so on and so forth. So far, the only intervention is made. The only interventions are made by social media managers, like let's say Facebook's managers themselves or Twitter managers themselves. I mean, blocking or unblocking a given account deciding whether a naked breast is allowed, whether Nazi symbols are not, all this kind of stuff. I mean, they have a superpower in deciding, because I mean, we know that those things, you know, can circulate and affect the you know, judgments of entire populations. So I mean, now these organisms are somehow extra-national. I mean, they cross the borders, and essentially they also have, in terms of regulation, that are not discussed or agreed upon with anybody else but a private society or a private company. I mean, this I think is also something that needs to be addressed in terms of, I mean, how do you, professional lawyer, or let's say, in a sense, representative of the let's say, the law in a given state or country, interact or deal with, you know, people that do the same job, but, you know, in a complete private sector that cannot be interfered with. So this, I think, is something that it's escaping our control to some extent. So the power that these companies acquires in, you know, that in most of the cases exceeds the one of the states themselves.
So this is one of the many facets of the problem, because those who control the environment actually are few, and they cannot be put on check by states. One of the most interesting aspects that has not really to do with with big data, but still with artificial intelligence, was when some years ago a federal judge issued a warrant requesting that Apple create a backdoor to the iPhone of somebody who had slaughtered many people in the San Bernardino massacre. And many questions arose. Can he ask Apple to do that? Can Apple say no? Oh, how can we know whether Apple is right in saying no, I can't? Because Apple said, I can't. So the statement by Apple was, we will never do that, and we are not able to do that. How do we know whether they are able to do that? Because if you don't comply with a warrant, you're liable. But how can you know? Since you hold the techniques, the technology to do that.
Just to mention that, for example, we'll see in one of the seminars this also kind of problems. So about, let's say, the role of open access, open source codes versus private codes. So these are also some important topics that we will tackle in this line of seminars. And let me also tell that I think one of the points is that so, of course, the powerful, or the power of many companies in this asymmetry of powers is also allowed by us somehow, right? Because basically, we give consent of giving up our information for the services. And of course, just want to say that I think that we need to understand better these kind of processes, because somehow there is nothing already decided. Many things are under discussion. The questions are open. And so if we want to take part of the process, we really need to be aware. So this is why we think that also for students this is a fundamental challenge to understand what is going on and what's the impact. Professor from Bristol, colleagues of Filippo Simini that was student here, was doing these similarities with the environmental problem when there was the increasing of pollution and so on, and there was this environmental movement that actually at the beginning seems too weak to do something, but then basically introduce a cultural shift. Then this then spread out. So I think that one of the points is also to understand if and where there is this possibility of cultural change, I think, that may have an impact also on these kind of processes. Yes?
Good afternoon. My question is, how much the internet society is biased reflection of our society, and how much is just a whole different society? Because many people don't participate actively in the internet. I'm referring to, older generations, but also to younger ones that just don't want to. So if we use internet trends to judge real society, aren't we making a big disadvantage to those people who don't participate in the internet?
Yeah, just a word. And well, I think that this is another critical point. There is kind of polarization in, let's say, prompt technology people that use every day, and then there is maybe kind of people that don't use the technology. But this also is there is this kind of bias in the web. Let's say, of course, they are. We know. I mean, we experience that there are bias that basically reflect the bias that we have also in our real society. That in turn reflect also, if we think about what is happening, for example, in basically all the world, in many political or also, for example, in the recent event with the UK escaping from Europe. So these are all effects that we see basically in terms of the power that the feedback, let's say, the feedback that from real world to the web and the web from the real world. So these are really complex dynamics, and this is also another point that we want to.
One facet of a question is good for philosophers, which I'm not. Certainly the technological gap is huge among generations, and this has reflected itself into a certain biography-driven market. It's hard to tell how much, and that's a question for other disciplines probably, it's hard to tell how much social media are reshaping language, which is another part of the question I think is involved in your line of reasoning. But on overall, this is sort of a disclaimer, because I think this ties back to what I said about the judge and the trial in which somebody defended saying, well, if the average society thinks it's decent to say something, I can say, I just made it up. So it's when lawyers try to plead not guilty in order to save the people who are charged. So I wouldn't say that is good argument, that it's obvious arguments that would come across in any tribunal. I'm sorry for downplaying the question, but the technological gap is clearly embedded in the phenomenon. But even in nuances that it's hard to predict. So for instance, when New York was flooded 2 years ago, there was a huge wave, and because of weather storm, New York was flooded, and the municipality tried to track down which parts of the city were most heavily hit, and they got it wrong, because they were basing their statistics on who was tweeting about the thunderstorm or the flood, who was Googling what to do in case of thunderstorm, or was email or something. Actually, those who were most severely hit had gone out of electricity. So they weren't visible anymore. So that gap can happen for many different reasons.
Okay, so if there are no more questions, I want to thank you and also thank Professor Pin for being here. And we will see you to the next seminar. Thank you.